In this video, we want to use properties of logarithms to rewrite each of these logarithmic expressions as a single log. So I've shown this list of properties in the last video and others. So here are the properties of logs. Got the definition over here on the right side. The ones we'll be using this one right here. It says if you have a log of a product, you can write that as the sum of those logs of the respective factors. And this works both ways. So it might be given in the form that you have here on the right side. You want to go this way. The same thing with this one here. You have the log of a fraction to some base a. You can write that as a difference, the log of the numerator over the log of the denominator, and this goes both ways. You can have something like the right side, a difference, and write it as a log of a fraction. We'll be using this one right here also. If you have a log of some number to a power, this power can become a coefficient. Could be the other way. You could have it in this form here, and then this becomes an exponent. The coefficient becomes an exponent. So for the first one, we have the log of some expression minus 2 times the log of x plus 1. So log of x squared minus 1 minus 2 log of x plus 1. The base is not indicated because remember, if it's log and no base, it's understood to be base 10. If it's ln with no base, that's understood to be base e. So we'll start the first one by writing it this way. This will be the log x squared minus 1. Now I could take this minus 2 is a coefficient, consider that a coefficient. That could come as an exponent, but I'm going to leave the minus there. Just take the 2 and put it over here. So this will be the log of x plus 1, quantity squared. So now once I have it in this format, I have a difference of 2 logs, same base 10. I can write that as the log of a fraction. So this would be the x squared minus 1 over x plus 1 squared. And then we can simplify this. X squared minus 1 is x minus 1, difference of 2 squares, x minus 1 and x plus 1. And here we have a factor, 2 factors of x plus 1. So we can cancel one of these with one of these over here. So this will be the log. Again, we cancel one factor of x plus 1 in the numerator, left me with an x minus 1. Canceled one factor of x plus 1 in the denominator, left me with 1, x plus 1. So we've taken the first one then, a difference of 2 logs, and wrote it as a single log. The log of x minus 1 over x plus 1. And again, the base is understood to be base 10. Now for number 2, we're going to use the property that allows you to bring the coefficient as an exponent. So this is going to come here. Again, here I'm going to take the 2 only and leave the minus there. That'll become an exponent here. And over here we don't need it. So this is going to be ln. The power comes over here. So it's x squared y taken to the 3rd power. So it's x squared to the 3rd power, multiply the exponents there, power to a power, so it'll be x to the 6. And then again, this is through here, and power to a power, this is y to the 1st, so it's going to stay y to the 3rd. And then we put parentheses on this because it's the log of that whole thing there. The next one, again, I'm going to take the 2 over here, leave the minus there, so this will be ln x to the 2nd, so it'll be x squared. And then z to the 2nd here, z squared. There. This comes over here. We get this. Leave the minus there. We don't have to. We could take it, put the negative 2 over here, but then you're dealing with negative exponents. So just leave it like that with a 2, x squared, z squared. And then I have plus ln of x, y squared, z squared. So what I'm doing here, I want the coefficients of the log here to be either a 1 or a minus. or a plus. So let's do this now. I'm going to do these two here first. Here I have a difference of 2 logs, so one of the property tells me that I can write that as a single log by forming a fraction. So in other words, it's going to be this quantity over this quantity. So this will be x squared y to the third over this one here. And I could do this, I incorporate this actually, say this, okay, now I have a plus the log here. So I can write that as a product. But I'm going to do it in steps here so you can see what we're doing here. So it's going to be like this. And then it's going to be plus ln of x y squared z squared. Now I can look at that as a sum of 2 logs. Going back, I can write that as a single log by taking the log of the product of these expressions here. But before I do that, I'm going to simplify this. Simplify the first part here. So here we have an x squared and a z squared and a y to the third. So let's write this one like this. Let's reduce it. We could wait until the end, the last step here, but we have an x to the 6 and a y squared, so this simplifies. 2 factors of x will cancel 2 factors of x in the numerator, so that'll leave me with an x to the 4th up here. And then nothing I can reduce here, so I'm still going to have a y to the 3rd up here. And that's all going to be z over z squared. And then it's plus, it's going to be like that. It's still ln of x y squared z squared. So now I have the sum of 2 logs. So using one of the properties, again, of logs, the one that goes from a product to the log of the one that goes from a product to a sum, and then vice versa. So you can go from a sum to a product. So in this case, this will be ln, the sum goes to a product. So it's going to be this, these two multiply each other out. So I'm just going to do it this way. Multiplying these, this expression here and this one. So notice this has a z squared up here in the numerator. So this z squared and this z squared will cancel. So now the denominator for both of these is 1. So we just have the numerators here. So what do we have? X to the 4th and an x. That'll be x to the 5th here. And then we have a y to the 2nd and a y to the 3rd. That'll be a y to the 5th. And that's it. Z squared and z squared cancel. X times x to the 4th is x to the 5th. Y squared times y to the 3rd is y to the 5th. So the single expression for this one then, for number 2, is natural log of x to the 5th, y to the 5th. Thanks for watching. We'll see you next time.